Hi everyone, in this video I'm gonna talk about the sampling variability as it applied to statistics or in deep learning, for example, right here. Now, sampling variety, a lot of time when we try to measure a parameter for a population, let's for example the weight, the age, or the height of a population, there's no way we can take the entire population and average and measure and take the average of that. So a lot of time we have to sample a population. Let's say, for example, our population of 1 million, we might have to do sample of 1,000 and get the average of that right there. But if you do the sampling like that right there, the result from a single sample like that can be untrustworthy or unpredictable compared to the population parameter. For example, the average age of the entire population. So the measurement or sample may be untrustworthy estimate of a characteristic of population. And the reason why there's variability in sampling is because, for example, we may have measurement noise, may have natural variation, we may have natural randomness or system complexity, for example. So one way we can take into account of the sampling variability is to do a lot of sample, because when we do a lot more sample, we can use the laws of large number to estimate the population mean. So basically, what it means is that if you take a lot of sample like that right there, and you take the average of that sample, then that average right there is going to approach the population average for that particular parameter. So if you take a look at this example right here, right, I have 30 random numbers between 1 and 100. This right here could be the age of a population, for example, right here, right? And of course, right, we're gonna import NumPy and we're gonna import matplotlib to plot the result later. So if you take a look right here, right, I take the length of the population right here, and here I calculate the population mean using the np.mean method right here. And then here, I'm going to sample a population out of a size of 7. So I'm going to take 7 random number out of this population right here, and I'm going to put in this variable sample right here. And then I'm going to take the mean using numpy.mean method to take the mean of the sample right here. And I'm going to print out the population mean and the sample mean. And you can see right here, right, it there's a little bit of difference between the sample mean and the sample population mean and sample mean. So if I run it again one more time, for example, right here, right, you have a different result. Run one more time, you have a different result. But you see that there's a difference between the sample mean and population mean. Now, what happens if we run this again, this process again, but do it for 1,000 times? So in here, I have I create an array of sample mean of 1,000 right here, element. And then for each element right there, I'm going to go through each one of them, take a random sample. I can do 5, for example, in this situation right here. Okay. And I can, and then I would take the mean of that sample. I store that into the array right here. And so just come on doing that until 1,000, right? At the end, I'm going to take the mean, the average of the sample mean right here. And then you see that it's kind of approximately close to the population mean right here. Okay. And then what I did right here is I just create a histogram, and I plot the population mean at this straight line right here so that you can see. And then in here, for example, you can vary the number of runs. You can do, like, instead of 1,000, you can do 10,000, and then instead of 5 right here, I can do 17, for example. Right? So run it again, and you see that the sample mean and the population mean approximate each other right there. So basically the law of large number is that as a number of identically distributed randomly generated variable increases, their sample mean, the average approaches their theoretical mean. So basically what it means is that if you increase the number of sample right here, instead of doing just one sample run, you do like 10,000 sample run, and then for each of those sample run, you take out an approximate example of a population. So instead of doing on 30, you do 17 right here, or do 5. And then when you do large number enough, the two average tend to approach each other right here. Okay, so this is right here is just a simple overview of sample variability that is used a lot in statistics and deep learning. I hope you enjoy and learn from this video. If you like it, please give it a thumb up, give it a like, comment, and thank you and have a good day.